We are reviewing 1.2 mass spectra of elements, a very interesting lesson. Before that, we have a mass spectrum. What is mass spectrum? Mass spectrum is it shows the isotopes of an element and their relative abundance. So you can look here. This is called a spectrum. So you on the y-axis you have relative abundance. So most of the time it is given as percentage, and over here you have atomic mass unit, or sometimes it is mass to charge ratio. So Z is the charge and charge is +1 for your level. So it's simple. So over here there's one more term, isotopes. Isotopes means you're gonna have the atoms of same element. Like you have carbon 12, carbon 13, carbon 14. So they are all atoms of carbon. The atomic number gonna be same for all of them, but the atomic mass or the mass number gonna be different. Because of that, the number of protons and electrons, they have got same number of electrons and protons. When you calculate the neutrons, they become different. So this is 6, 7, and 8. So another definition can be same number of protons and electrons, but different number of neutrons. So that's called a isotope. When you have got this spectrum, it reveals a lot of good information. So you can see here these are called peaks. So there are 3 peaks. 3 peaks means there are 3 isotopes. So each peak corresponds to a single isotope. So if you see 7 peaks, it means there are 7 isotopes. And isotopes means they are atoms of same element. Taller peaks, you can see here the height of the peak is varying. The taller peaks means more abundant isotope. So this is here. So this is, I assume it to be X24. The abundance of this isotope is too much as compared to isotope with mass 25 and isotope with mass 26. So taller the peak, more abundance. You will find more atoms with that atomic mass or mass number. So you can have a spectrum as you just saw, or you can have a table. Over here there are 3 isotopes. The mass, atomic mass for each isotope is given this way separately, or it can be mentioned like this, both perfectly all right. And this is the relative abundance, which is in a percent. The mass spectrum shows 3 peaks. It means there are 3 isotopes, and you have to use this information to calculate the average atomic mass. Now you have 3 isotopes of neon. So neon will not have exactly the mass of 20, 21, 22. No, rather it will consider all the isotopes to calculate the average atomic mass. How do we calculate it? It's a very simple formula. Average atomic mass is equal to summation of isotopic mass times fractional abundance for isotope 1 plus similarly for isotope 2 and so on. Let's solve a question so that you develop a secure understanding. The mass spectrum shows a peak at mass to charge ratio. So M stands for mass and this stands for charge. And the charge you will always have +1. So you don't need to bother anything more than this. And you will always have only elements, no compounds. So there are 2 peaks, 63 and 65. Which conclusion is most reasonable? The element has 2 isotopes. You can see here there are 2 peaks. Two peaks means 2 isotopes. Probably this is gonna be my answer, but let's check the rest of them. The element contains 2 different elements. I told you they will be same elements. The element has 2 ions with different charges. No, the charge will always be +1 at your level. The sample is a compound. As I told you, will always have elements. You won't have compounds. So the answer gonna be A for us. It's solving a question is all about getting important terms which you must know and use them to answer the question. Okay. Next one, element. An element has two isotopes. So we can see here there are two isotopes, 35 AMU atomic mass unit and 37, and they have given the relative abundance. What is the average atomic mass? Probably you would have guessed the right formula. So average atomic mass is calculated as 35 times, so isotope mass and its relative abundance, so 75%, so you'll divide it with 100. So this is for one isotope, plus 37 times 25 divided by 100. So I want all of you to take a pause and solve this question for yourself. So if I simplify for myself, 35.0.75 plus 37 times 0.25. Be mindful about there is a multiplication sign and there is a plus sign when you add the two isotopes. So you get the answer to be 35.5 AMU. So answer gonna be B. So simple calculations, be mindful where can be a error. So you have to divide this percentage by 100 so that you get a fraction, and the multiplication sign between the isotope mass and times fraction, and then you're gonna add the mass of all the isotopes. All right. Next question, I want you to pause the video and try to solve it by yourself. All right, let's check your answer. A sample of boron contains two isotopes. Calculate the relative atomic mass. So average atomic mass. So how we will calculate it? It is equal to 10 times 19.9 divided by 100 plus isotope 2, 11 times 80.1 divided by 100. So I want all of you to pause the video and get the calculations done. .801, so you're gonna say 10.8 AMU. So this is how you will solve the next question. A sample of magnesium is analyzed using a mass spectrometer. So mass spectrometer is a device for getting the mass spectrum or measuring the average atomic mass. The mass spectrum of magnesium is shown below. Use the mass spectrum below to determine which of the following values is closest to the average atomic mass of magnesium. So very simple question. Earlier you have done it in a form of a data as in the previous question, but now they have given you a graph. The method stays the same. You have to just use the graph. How are we going to solve it? So this is isotope with 24. So you will have 24 times 78.99 divided by 100 plus you have three isotopes. There are three peaks. So 25 times 10 divided by 100 plus you have 26 times 11.01 divided by 100. And you're going to solve this question and you're going to get your answer. So This is 18.9576 plus 2.5 plus 2.8626. So adding them all, so you get answers to be 24.32 AMU. So my answer gonna be B. Next question. The mass spectrum of an element shows 7 peaks. So 7 peaks means 1, 2, 3, 4, 5, 6, 7. There are 7 peaks. 7 peaks means there are 7 isotopes. They did not mention, so you don't have any labeling here. So you don't need to do the calculations. You can solve this question without calculation. Just need a small trick. Look at the relative abundance of one of the isotope. You can look here. This is 10, 100, 102, and the relative abundance of this isotope is the maximum. It means the mass gonna be closer to 1.02. I'm saying closer, not exactly 1.102, because you have another isotopes as well. So they're gonna contribute to the average atomic mass of the compound. So answer gonna be closer to 102. So this is not closer. This is not closer. I told you it can't be, because you have 104 isotope but not that abundant, so it can't be this one. So answer gonna be C. So you didn't do any calculation. You have just to use the trick. Look at the peak which has got the highest abundance. The mass gonna be closer to that but not exactly that. Is this clear? Next question, and interesting. You need a good read. A chemist analyzes a gaseous sample of single element using mass spectrometer. The instrument produces mass spectrum showing several peaks at different mass to charge ratio. So you can visualize this in your mind, or you can quickly draw it roughly for you. It's a long question. So there are 5 major peaks. You have 64, 66, 67, 68, and 70. And they have given the relative abundance of all the peaks respectively. So this goes for this goes for this. This is how it gonna be. Answer the following question based on the information provided. Based on the peak observed in the mass spectrum, determine the number of isotopes. So isotopes means is equal to number of peaks. And how many peaks do you see here? 1, 2, 3, 4, 5. So how many isotopes are there? There are 5 isotopes. If you have to justify, you can say because there are 5 peaks. There are 5 peaks. Explain how the relative abundance and the mass of each isotope can be used to calculate the average atomic mass. So you have to calculate the average atomic mass. Your explanation should describe the calculation process conceptually. So you have to show your calculation. How will you do? Very simple. So average atomic mass is equal to 64 times 49 divided by 100 plus 66 times 28 divided by 100 plus 67 times 4 divided by 100 plus 68 times 19 divided by 100. I'm running out of space, so I'm putting plus, and over here 70 times 1 divided by 100. And you're going to solve this and you will get your answer as AMU. Continuing the same question, it's part C. The calculated average atomic mass of the spectrum is approximately 65.4 AMU. Using this information and the periodic table, identify the element. When they say identify the element, so you have to name the element. It is the average atomic mass is 65.4. So it's quite blurry, but I can see here it is 65.38 for zinc. So zinc is 65.38, which is closer to 65.4. So I will say the element is zinc. Then next part, write the ground state electron configuration, very important, of a neutral atom of an element identified in part C. So what you say zinc. Now you're going to write the electron configuration. So you say it. So zinc, when you go into the periodic table, it has 30 electrons. 30 electrons. As you know, atomic number indicates the number of electrons when it is a neutral atom. So configuration gonna be 1s2, 2s2, 2p6. So you have 10 electrons. 3s2, 3p6, 4s2. So you have to remember 4s2 will come before 3d. So first check. So you have 10 electrons, 12, 18, 20, and here you will have 3d 10. So this is my electron configuration for the zinc. If you don't remember the electron configuration, we're going to review it soon in the upcoming videos. Now practice more questions.